Hi everybody, this is MNTC P06 Foundational Chemistry. I am Eric Tremblay. Right now we're in Module 1, Week 2, and I'd like to spend a couple of minutes with you discussing precision versus accuracy, and we'll go through a tiny example. Let's go do it. Okay, so when you're working in chemistry, or any science for that matter, you're going to sometimes come across things that are called exact numbers. They have no uncertainty associated with them as well. So I'll give you some examples here. If you're stopped at a stoplight and you look at the car next to you and you see there's two people in the car, and if you have a good look into the back seat and you can't see anybody, then you have very good certainty that there's two people in the car. It's not 2.5 people in the car. It's not 2.1 people in the car or 1.9 people in the car. It's two people in the car. There's some exactness to that particular concept, and it doesn't really change. It's two people. If you asked someone else to go take a look in the car, if there's nobody in the back seat, they'll say, yeah, there's two people in the front of that car, in the front seat of that car. Here's another example. If I reach into my pocket and I pull out 5 quarters, okay? If I take those 5 quarters and I show them to you and I say, how many quarters here? You're going to say 5 quarters. You're not going to say, there's 4.5 quarters, or there's 4.8 quarters. And your friend, if they did the same thing and looked into my hand, they wouldn't say, I think there's about 5.2 quarters there. No, it's 5 quarters. There's a lot of certainty behind that particular number. And now, if I just tell you the number 19, okay? If I say you're the manager of a quarry and you've got 19 dump trucks in your fleet, then if you went and counted them, you would count 19. You're not going to count 18.7 dump trucks. You're not going to count 19.1 dump trucks. You're going to count exactly 19. So if I give you the number 19, that's an exact number. Now, not all the numbers you're going to encounter in physical sciences are going to be exact numbers with no uncertainty. Oftentimes, you're going to have to measure something. In this particular course, you're going to do some labs. So when you measure things in the labs, that's when you will have some uncertainty. So these are called measurements. So anytime you measure something, know to yourself that there's some inherent uncertainty around it. I'll let you know what I mean. So if you wanted to measure my height, okay, the height of a person, okay, and you might measure me and say, okay, I'm 184 centimeters tall. Is there some uncertainty there? Like, are you really sure that I'm 184 centimeters tall? Could I be 184.1 centimeters? Could I be 183.9 centimeters? It's quite possible, right? So there's uncertainty in that given measurement. You know, there's all kinds of things like how you use the ruler, how was my posture that day, you know, what angle you were at when you made the measurement, for example. So there's uncertainty in that number of 184 centimeters. Likewise, if you measure the pressure on your car tire using a tire gauge, and it comes out at 264 kilopascals. You've probably done this before. You could go back with your tire gauge and measure it a second time. What's the likelihood that's going to read 264 again? It's actually pretty poor. Usually those tire gauges and the way that we're measuring pressure in that setting are not really, that good. And so you're going to get uncertainty. Sometimes you'll measure it, it'll say 262. Other times you'll measure it, it'll say 260. A third time might say 264. There's inherent uncertainty around that measurement. Here's another example. If you're working in a quarry with those 19 dump trucks over here, and someone says, okay, you got to move that 1-ton rock. Does that rock really weigh 1 ton? Could it weigh more than a ton? Could it weigh less than a ton? There's uncertainty in that measurement. That 1 ton is just really an approximation of the weight. Okay? If you measure it and it weighs 1 ton, then there's some uncertainty in that value. So I just wanted to focus now on not exact numbers, but just on measurements. Okay? Many times in this course, you're going to take measurements. So let's just talk about measurements for a second. When we talk about measurements, there's 2 concepts you need to know. The first is precision. The second is accuracy. Okay? So I'm going to spend some time with these 2 things and I'll show you some examples. How about precision? Precision is defined in your textbook as how close various sets of measurements are to one another. Okay? But inherently it requires multiple measurements in order to do this. okay? It requires multiple measurements because it's how close various sets of measurements are to one another. So you need comparables, okay? And it's often reported as an average, for example, or this data. And then let's talk accuracy for a second. Accuracy is how close a value is to the true value. So it's how close your measured value is to the true value. Notice you don't need multiple measurements to do this. You can take a single measurement, and then if you know the true value, you can compare, and then you can judge how close you are to the true value. All right. Let me show you a diagram that really helped me when I was learning this concept. It's this idea that if you had a target, doing target practice here with a paintball gun. Okay, so this is your standard target. This is your bullseye that you're trying to hit. Okay, this is your first outer ring, your second outer ring, your third outer ring. So just pretend you had a paintball gun, paintball marker, and these are your paintballs, and you're taking a shot. Okay, here I got 7 shots. 1, 2, 3, 4, 5, 6, 7. There's 7 shots on the target. And let's talk about the concept of precision and accuracy in this context here. These particular shots are really scattered all over the place. They're scattered all over the place. So if you compare them against each other, you'll know that they're not precise. Okay, they're not close to each other. So this is an example of something that's not precise. My shots as a whole are not particularly accurate, really. I only got 1 in the bullseye. I got the majority of my shots outside the bullseye. So there's poor accuracy in this particular diagram. So people can envision this as low accuracy and low precision. But I'll show you a different kind of diagram. What if I walked up to the target and I took my 6 shots this time and they were all like this, all tight together right here? So if I compared the values against each other, oh wow, they're very close to each other. That means I have a high degree of precision. High degree of precision. Now, the problem is I completely missed the bullseye. Okay? Nothing is in the bullseye. Remember, accuracy tells you how close you are to the true value. And if the true value is trying to hit this middle of this bullseye, if that's what I was trying to do, then I'm way off. Okay, I'm way off here. I missed the center of the bullseye. So I am not accurate with these shots, but I'm very precise because I'm hitting the same spot every time. So a diagram like this can help you understand what the difference is between having low accuracy and a high precision situation. There's still another way you can think about it. Now, look at this. I'm a lot closer to the bullseye here, right? In fact, I have 4 of the 7 shots, the majority, are actually touching the red bullseye circle. So the accuracy in this situation is much better. It's certainly much better than over here. Over here, I was very far away from the bullseye. Here, I'm in the neighborhood. So the accuracy is a lot better. But let's talk about precision for a second. How close are these values to each other? Well, you know, they're not bad. They're not as bad as up here. Up here, it's completely way far away from each other. Are they as good as here? Are they as tight as this little cluster here? No, no. If this is highly precise, then this is far from highly precise. So one way that I like to think about this diagram is, oh yeah, you're getting accuracy, but your precision is still lacking. So you can think of this as highly accurate, but the precision is still lacking, low precision. Now the last diagram that I'll show you is this one here. It's sort of the ideal case. This is if I was really, really good with my paintball marker and I put all 6 shots right in the bullseye. Okay, are we accurate? Yes, we're completely accurate because the true value is the bullseye. We hit the bullseye. Okay, that's a high degree of accuracy. Are we precise? Yeah, we are precise too. The tightness of this cluster is in fact very, very good, and so that means our measurements are precise. So this is one way you can think about high precision and high accuracy. So these 4 diagrams collectively taken together can help you understand and remember what the difference between accuracy and precision is. And let me know if you like this diagram. Now at the beginning of this video I promised you a worked out problem on this. I think I'm going to actually stop this video right now and I'll do the worked out problem in a subsequent video. Okay? So keep your eye out for it. Thanks.